Now, the time of chapter 2 physics, it's about scalar and vector physical quantities. From the previous lesson, we know that physical quantities can be classified into two types. The first type is a scalar physical quantity. Scalar physical quantity, it's a physical quantity that has magnitude only, or which is known by knowing its magnitude only, like distance, mass, time, temperature, and energy. Number two, or the other type, is a vector physical quantity. It's a physical quantity that has magnitude and direction, like displacement, velocity, acceleration, and force. Note that when we deal with a physical quantity, you have to note that if the physical quantity resulted from multiplying or divided two scalar quantity, the result will be scalar. Two vectors quantity, the result also will be scalar. While when multiply or divide vector by scalar, the result will be vector. Now let's know what is the difference between distance and displacement. Distance is the length of the path moved by the object from one position to another. On the other hand, we can say that, we can say that distance is the actual length done by the object from starting position to final or end position. It's considered as a scalar quantity as it has magnitude only, and we know that the unit of distance is meter. While displacement, it is the length of the straight line in a given direction between starting point and ending point. Displacement is a vector quantity that needs magnitude and direction. Notes: if the object moves in one direction from point A to point B, the distance will be equal to displacement if the object moves in one direction. Number two, if the object moves from AB, then return back to the starting position. So displacement in this case will be zero, as it moves in the opposite direction and it has negative sign. Displacement in this case is zero, while distance is double the amount of AB. If object moves in a curved path, distance covered by the object is more than the displacement covered. Vectors representation. Vector can be represented by drawing a straight line on the vector that represents its direction. In this case, if we have two vectors in the same direction and same magnitude, so they are equal. If we have two vectors equal in magnitude but opposite direction, so A equal negative the other vector. Two vectors are considered equal in case they have same magnitude and same direction, even they have different starting point. Resultant of two vectors. If we have two vectors like in this figure, vector A and vector B, to get resultant or adding this vector together, we have two ways to get the resultant. Number one, by drawing triangle like that. Vector A in the same position, but starting from vector AB will be at the end of A, like this figure. So C resultant will be moved from A to B, like that. This is the first way. Vector C equal A plus B. The other way, by drawing parallelogram like that. This is vector A in the same position, vector B starting, vector B will be at the start of vector B like that, and we'll complete the shape as parallelogram. So C diagonal considered as a resultant of two vectors, C equal A plus B. Resultant force, it is the single force produced the same effect of an object as produced by original acting force like that. In this boat, it affected by F1 and F2. The F1 and F2, what is the effective force will allow this boat to move? F1 or F2? No, there is other force give the same effect of this force known as a resultant force, and it will move in this direction. How can we get the resultant force? If the object moves with 40 Newton and this is 30 Newton, note that the angle between them is right. In which direction it will move? 40 or 30? No, the other direction, which known as resultant, like that, and by calculating it, it will be 5 Newton. How can we calculate it? F1 40 Newton is normal to F2 30 Newton. The resultant will be moved between them like that. This is the resultant force. By using the idea of Pythagoras theorem, we can get F, which is considered as hypotenuse. So F resultant will be F2 square plus F1 square under the square root. And also we can get this theta or this angle by getting tan theta, which equal Fy over Fx. Example: find the resultant of two forces, one in the direction of x-axis before Newton and the other in the direction y-axis, which equal 3 Newton. Okay, draw it like that. This is Fy and this Fx, so the resultant will be moving this figure. By using Pythagoras theorem, force equal root Fx square plus Fy square. It will be root 16 plus 9 will be 5 Newton. So the tan theta will be equal Fy over Fx. So tan theta 3 over 4. How can we get theta from this? By using calculator, shift tan 3 over 4. So the theta will be 36.87 degree. Vector analysis or resolution. This is a reverse process of adding two vectors or getting the resultant vectors. Look at this photo or picture. This man tried to pull this box or small pot by trying to pull it by force that make angle with horizontal. We can resolve this resultant force into two dimension Fx and Fy like that. Okay. From this, Fx equal F cosine theta and Fy, the force in one dimension, will be F sine theta. Example: girl pulls another girl by rope using force 20 Newton. This is the force. In a direction that make angle 30. This is theta. Find force components. Components here refers to x direction and y direction. So we have to get Fx and Fy. Okay, Fx equal F cosine theta, so it will be 20 cosine 30, and the answer will be 17.3 Newton. Fy is F sine theta, 20 sine 30, the answer will be 10 Newton. Another solved problem. Two perpendicular forces Fx and Fy act on the object where Fx and Fy they are equal. Okay, the 18 Newton. Find the number A, the resultant of two forces F1 and F2. The angle between the resultant on y-axis, which is known as theta. Do the object move or remain constant? Number A, F equal root Fx square plus Fy square, 80 power 2 plus 80 power 2 under the square root. The answer will be 113.13 Newton. Tan theta will be x or y over x, 80 over 80 shift tan, so the angle will be 45 degrees. Does the object move? Yes, it will move. Vector product or multiplying two vectors. If we have two vectors A and B, they have angle between them theta. We can get the product of them by two ways. Number one, scalar or dot product. Dot product of two vector equal A dot B, it's pronounced by dot, equal AB cosine theta, while vector or cross product can be expressed by the following: C equal A cross, this is pronounced by cross, A cross B equal AB sine theta N. N is the unit of vector perpendicular of both vector A and B. C is perpendicular to both A and B. The sign cross pronounced by cross, as we said. Vector C points to the direction of N perpendicular vector A and B. Notes. Number 1, A dot B equal B dot A. Number 2, A dot B will be 0 if theta equal 90, as A dot B equal AB cosine 90, 0. A cross B not equal B cross A, but equal negative B cross A in the opposite side. A cross B will be vanished or 0 if theta 0 or A parallel to B. Right hand rule. Right hand rule, it is a rule which is used to define the direction of C vector between two vectors, resultant of two vectors. The opposite figure, direction of C is determined by right hand rule. Look at this, if this is vector A and the hand vector B, so the sum refers to the vector C. Sum is normal to both A and B. By moving fingers right hand first vector toward the second vector cross, the small angle between them shall be some points for the resultant vector C, like this figure also. Example, if the magnitude of two vectors A and B 5 and 10 respectively units and the angle between them is 60, find the value of dot and cross product. From the rule, A dot B equal AB cosine theta, it will be 25 unit. C, A cross B, AB sine theta n, it will be 43.3 n. We have to know C is the resultant vector having magnitude 43.3 and direction n perpendicular to the plane A and B. Another example, A and B are two vectors, the angle between them theta يعني 120 between them, where the magnitude of A equal 3 units and magnitude of B equal 4 units. Find their dot product and their cross product. Okay. A dot B, as we know, equal AB cosine theta. A multiplying B 12 cosine 120. So the result will be negative 6 units. A cross B from the rule, AB sine theta n equal 12 sine 120. It will be 6 root 3